Hello guys, welcome back to the channel. This is Abhinav, and so today we will be starting with our new series of problem of the day life. So from now onwards, we will be having live problem solving of that problem of the day that you all have every day at 12 means at 12 a.m. next day. That is means if you the problem which is basically given you on that's it's 1st November that we are going to discuss today, and we will solve it from now onwards. Okay, so we will have these live sessions of all the problems, all the problem of the days. Okay, at this 12 a.m. just after the time of that problem. Okay, so that's what it is. So just first, let me confirm, guys, that if I am clearly audible to everyone. Am I clearly audible to? There are some three people. Okay, let me confirm it. Yeah, okay, so I am. I am. Yeah, good morning. Okay, guys. Okay, guys, so let's start with the problem only. Uh, let me share the problem. Just a minute. Okay, okay. Fine, guys. So I hope that now my screen is visible to everyone. Now the problem which is was today was means on 1st November was median in a row wise sorted matrix, and we are going to basically solve this particular problem. The problem is here. So you are given with a matrix basically that matrix is sorted row wise, and we have to find the median of that particular matrix. We have to find the median of that particular matrix. Okay. So what is the median? Median is that how we can define the median of any number. So median of any number is defined as something like if we arrange all the numbers in an increasing order, so the middle number is called as the median of that array. The middle number is called as the median of that sequence of elements of that elements. Okay, so that is what the median is. So we have a complete array that is a sorted array, and the middle element is called at the median element. Okay, that's the middle element. Fine. So it's just like the middle. Median means middle. Okay, we are talking about the middle element. Fine. So that's what median is. I hope that everyone knows that what median is. So if you are just write a plus one so that I can know that yeah, you guys are listening to me and you're understanding what I'm saying. Okay. So just write a confirmation text so that you guys are listening. Also, we don't have much viewers now because yeah, I know that the time is quite late. But yeah, to whoever all over who are just watching this stream, just give an agreement on whatever if you're understanding or not, so that it will be okay from my side too. Great, guys, great. So it's great that you guys are here now. Amazing. So we have to find basically a median in a row wise matrix, and that's exactly what we have to do. So you will see one thing here, guys. You will just see one thing here, that we have to basically first solve. We have to basically arrange the complete elements of a array first into their ascending order, and then only we can find the matrix. Sorry, then only we can find the median. Okay, let me just place my phone front off so that I can read the comments too. Okay, because reading comments is also very important. Yeah. So let me just define this thing to you. So let's take the example of the first row only. This is the first row. Let's take the example of this is the first matrix. Okay. So let's take the example of this only. So here you can see that this is the matrix is given to you. Hi Subham, hi. Great, Joel. All the best for your exam. So this is the matrix which is given to us. Okay. So it is containing 9 elements, and that's what it is. So if you will see, and if I will arrange this matrix in just increasing order. So it will be 1, 2, 3, 3, 5, 6, 6, 9, 9. Okay. And if I will just if I just ask you the middle of this array, so you will see that 5 is the middle element of this array. So 5 is basically the median of this array. Okay, acha. So guys, let's say that the case is key we have the case is that we have some r into c elements here. Is it fine? R is the number of rows and c is the number of columns. And we have r into c elements here in this particular matrix. So if I will arrange that elements here in this and in the form of row also, so that row will sorry, in the form of array also, so that array will also contain r into c elements. It will also contain r into c elements. Okay, in that array. Great. Now, guys, the next and the another important thing is key. What is the index of that middle element? What is the index of the middle element? If I will take the example of this case that we have written here, you will see here that it is 3, R was 3, and C was 3. So R into C was 9. Means there were 9 elements basically, which were present here. Okay, there were 9 elements which were present here in this particular case. Now for this 9 elements, what we will do? For this 9 element, what will be the middle element? Yeah. So we can do it like R into C by 2. That will be, in this case, it will be 4. In this case, it will be 4. Okay. It is at the fourth index. Got it? And if let's say that there was 6 elements, let's say these are the only elements. Okay, so in that case r into c was 6, so 6 by 2 is 3. So means yeah, Jatin, all the best for your exam, Jatin, all the best. Hope they will ask you that problem which you have already solved. Okay, I'm not sure about this problem, but I just wanted to push that they will ask you that problems which you have already solved. Okay, yeah. So this is the array which is given to us, which is 1, 2, double 3, and 5 and 6. Okay. Now, what will be the median of this, guys? So the median can be either this or either this element. Anyone can be the median. Okay. If you will see here, so here both the index are okay. So it is saying that where R and C are always odd. So okay. So R and C will always be odd. So this cannot be the case because if R and C both are odd, so obviously R into C will also be odd. So if this is the case, both R and C are odd. So if it is an array of odd length, so obviously there will be a unique middle element. So that will not be a case. That will be not that is not be a case. Okay, that's completely fine. Okay, now guys, amazing. Okay, now guys, let's understand that how we will basically solve this problem. That's the next thing that we have to understand. So, guys, what we will do? So, first of all, we want the maximum and the minimum element of this complete array. Okay, I just want the maximum and minimum element of this complete array. Fine. So we can easily find out what is the minimum element of this matrix and what is the maximum element of the matrix. That can be easily calculated. We can just iterate and we can just check that what is the minimum and maximum element of this particular matrix. Okay. You will see one thing, guys. You will see one thing. If let me just open here. Yeah. So you guys can just see one thing. Straight forward question हुआ अगर एक ही array में add कर सकते हैं. हाँ शुभम, we can add that, but let's try to do it in an order of one space complexity. Okay, so that will not be the case key. It can be done. Let's solve it in an effective way. Okay, so minimum will always be in the first column and maximum will always be in the second column. Last column, sorry, not the second column. So we will take the minimum of the first column and the maximum of the last column. So that will be the minimum and the maximum element of our particular matrix. Okay, so that will be a very obvious case. Now, guys, Yeah, that is the we are discussing about the optimized approach only, Shubham. Okay. Now, guys, the next thing, what we will do now, what is the next thing that we have to follow. Now let's discuss that thing. Okay, let's discuss that thing. So yeah, what we will do now, key we will first have this minimum and maximum element. Now what we will do something like a process similar to binary search. Okay, a process similar to binary search. We will apply binary search on answer. What is meant by binary search on answer? Binary search on answer means that we always say that we will first hit and try. It's just called a hit and try method. We first assume कि a particular number which we are taking is our median. We will first assume that thing. Okay. And then we will calculate it and whether it can be the median or not. And if it is the median, we will just go for it. If it is not the median, we will check for the another number. That is called the binary search. That is similar to the binary search approach. Let's see what we will do here. Let's see the approach which we are I am talking about. Okay. Let me explain you that approach. So this is the array. Okay. So in this array, just see one thing, guys. Let's say you can see that minimum element here is 1 and maximum element here is 9. So 1 is the minimum element and 9 is the maximum element that we are taking here. That is present here. Okay. Now, guys, what you will do, I will apply binary search algorithm in this range only. Because you will see, guys, that because minimum element of this array is 1, maximum element is 9. So, obviously, the answer will be between 1 and 9 only. That is a very obvious case. The median of the matrix will be between 1 and 9. So, what I will do, I will take a binary search between the range 1 and 9. Okay. So for binary search, the first thing that I will do is I will simply take its mid. So currently what we are doing, we are simply taking the binary search, okay, and we are taking the mid of it. So currently you can see that in binary search what we have the start and the end, or we have the left or right pointer. So here we have min and max. Okay, let's take in min and max. So or let's talk it left and right only. So let's say we are taking a binary search. So where min was 1 and max was 9. Okay. And what will be our mid? Can anyone tell me what will be the mid? So mid will be nothing but the average of it. So it will be just 1 plus 9 by 2. That is min plus max by 2 and it will be 5. It will be 5. Okay. That will be 5. Fine. Now guys, 5 will be here for sure. Now what I'm saying and why I'm saying it should be 5. So I'm saying it should be 5 because what we will do, we will hit and try that whether we will hit and try that whether our median can be 5 or not. How we will hit and try? So which number is median basically? A median is a number which is basically present on the mid, or we can say the number of elements which are less than median. Just understand this thing, guys. Please try to understand this. Okay, the number of elements which are less than median, or maybe less than equal to median, is equal to the half length. You can see that if the total number of elements in this matrix is R into C, you can see here this was the total number of elements in the matrix, and median was 5 because it was present at the mid. It was present at the mid. So how many numbers are there which are less than equal to mid? 4 numbers were there. That was R into C by 2. Is it clear? Just write a plus 1. Okay. Great. Great. So we will just check that how many such numbers are there which are less than the number which we are talking about. How many such numbers are there which are less than the number which we are talking about? Repeat once. Rupen, I am saying that if tell me, let's say I have written an array. Okay. This is the array I have written. So this is the median of it, that is the middle element. Okay, so if I will ask you, this is the median, is obviously that the numbers which are present before 6 will be half of the length of the array, because 6 is present in the middle. बस मैं यही बोल रहा हूँ that if there were 9 elements in the array and if 6 is the median, so 6 के पहले 9 by 2 elements present होंगे. There should be 9 by 2 elements before 6 in the left side of 6. That is a very obvious case. So that's all what it is. Fine. So now we will check that for 5 also. That how many such numbers are there which are less than equal to 5? How many such numbers are there that are less than equal to 5? Exactly. But Subham, how we will find this? That in first row two numbers are there. So let me now just try to observe one thing, guys. Just try to observe. For those who have attended my lecture of binary search that I have taken in the 30 days streak, I think that was the day 4 or day 5 when I've taken binary search. And on that lecture, I've talked about a concept of lower bound and upper bound. So if we have a sorted array and if we have to find that for a particular number, how many numbers are less than equal to that number, how we can find it? We can simply find it using upper bound. So if we take upper bound of a number, it will give me a position where a just greater number is present. You will see one thing that let's say in this case only, let's take for this case only, it is 1 3 1 2 first, 1 2 3 3 5 6 6 9 9. So tell me, guys, if I will find the upper bound for this particular number, which is 5, what will be the answer? What will be the upper bound of this 5? Tell me this thing. What will be the upper bound of this 5? It will be here. Okay, it will be here. Now we can easily find, because you can see that if I will give it index 0 1 2 3 4 5 6 7 8, exactly right, index 5 or element 6. Okay, so it is index number 5. So index number 5 means ki these are the elements, means all the elements before index number 5 are less than or equal to 5. So this is how we can calculate the elements which are less than equal to 5. Simply we can calculate that thing. The elements which are less than equal to 5. This is how we can simply calculate it. Okay. And we can just tell that, yeah, for this particular range, 5 elements are there which are less than equal to 5. And you can see that for each and every row which is present here, for each and every row of this matrix also, it is sorted. So we can apply the upper bound technique here also to check how many elements such are there which are less than equal to our element which we are targeting, that is the mid. Okay, so we can check that for the first case first. So for the first case, its upper bound will be something here. It is a virtual index, as I told you, the last index. So it will tell 3 elements are there. For this, it will be here. It will say 1 element is there. For this, it will be here. It will say 1 element are there. So total 5 elements were there which are less than equal to that part. And what is this 5? It is nothing but R into C plus 1 by 2. Guys, I am writing here plus 1. Why plus 1? Why plus 1? Because here we are also calculating this 5. We are taking upper bound. We are also cutting 5 here. That is why plus 1 is done. Because you can see that The median was at the fifth position basically. First, second, third, fourth, fifth. Getting? So we find such number who has this much number is a less than equal to that. So maybe the concept is not so clear because it is not that much easy problem for those who have just started. For those who know the concept of binary search, who know the concept of upper bound and that, it is a very direct question. Just write a plus one, guys, if you it is you are okay with it, and we will move towards the code part, the solution. And in solution also we will understand everything once again so that you can get it in a more amazing way. Okay, so should we move towards the solution part? Great, great. You can see the topics also. It is basically of the binary search problem is there, and we will obviously use the binary search technique only. Okay, ठीक है यार. Great guys. So yeah, exactly, Shubham. We are counting row wise, not column wise. Row wise, na first row, second row, third. I say it as row. These are the rows for me actually. I don't know. Okay. Great, great guys. So what we will do now? Okay, now let's see how we will solve the problem. So first of all, as I told you, to check the limit of the binary search, we have to simply find that the minimum and maximum value of the array. And minimum will be basically the minimum of the first column, and maximum will be the maximum of the last column. Okay. So I will simply take a particular two variables will be taken. Okay. And int min. So I will initialize int min with int max. Okay, and I will take int max and I will initialize it with int min. Obviously, if we are finding the max, so we will initialize it with min, and for min we initialize it with max. Okay, guys, have you all hit the like button? Please hit the like button now to get the reach of the video. Okay, so that's what it is. Okay, after this, guys, what we will do is key if okay Subham, yeah, so that's for another question. So let's say, guys, that if this value, thanks for telling that. So yeah, obviously this is let's say, guys, that middle was 4. Let's say middle was 4. Okay, we don't have to make it equal to that, Subham. We will always try to make it greater than equal to that, greater than equal to that. Okay. Okay, so yeah, maybe if it is less than. So guys, if it is less than, so what we do in the case of that? Let's say that in the case of binary search also, if the given value is less than a targeted value, then what we do? If the given value is less than a targeted value, so we try to increase our mid. We try to increase our mid, and that is what we will do here also. That is what we will do here also. If the given value will be less than desired values are into c plus 1 by 2. And if the given value we will calculate is less than that, so we will increase, means we will make our min is equal to mid plus 1. And if we have to decrease, we will make our min is equal to max minus 1. Just like the binary search. Okay, so let's implement it. Okay, so that you all will get it. So we will take a loop. So let's take it a small CRI. I'm not used to take the big values, and let's make it ARR. Okay. So it's like this. Now, guys, for finding the min, okay. So for that we will calculate it using this min, or let's make it mn and mx so that it cannot coincide with the functions. Also, we have inbuilt function called min and max. Min is equal to the min of mn comma ARR I0. Why I0? Because we have to find the minimum of all the elements of the zeroth column. And for the mx, we can simply write max of mx comma arr of I and c minus. So this is how we have just calculated the min and max of the given element. We have simply calculated the min and max of the given element. Okay. Now guys, the next thing that we will do is simply we will take a loop. Sorry, not that. We'll take a while loop. In that value will make min less than equal to max. Just like we do in binary search. So let me open a binary search also here so that I can relate you that thing. Okay. You can see here also a problem of binary search is given. So here also you can see first of all we have taken left is less than equal to r. Similarly here we have taken min is less than equal to max. Okay. Then we can find a mid. So mid can be simply mid is equal to min plus max by 2. Joel, but that will be more time complexity, na? More time and space complexity. But here the problem which we are doing, we will solve it using less space and time complexity. Okay. Now, guys, for yeah, Subham, but it is saying that rows are sorted. Maybe the case is that they are not sorted in column wise. हो सकता है ना ऐसा उन्होंने दिया तो नहीं है. Maybe they can say कि they are not sorted. They are saying row is sorted. Row wise sorted matrix है. Column wise it's sorted. We don't know. Is it sorted column wise or not? Okay. So that's why we are doing this thing. Yeah. Then for this number mid, we will find its upper bound for each and every value. Okay. For each and every row, sorry. So what I will do, I will simply take a row. I will make it like this. For each and every row, what I will do, I will find its upper bound. So let's say upper bound will be, we will simply use the upper bound function, which will be arr of I dot begin, comma arr of I dot end, comma mid, because we are taking it for mid now, for that number for mid which we have taken now. And we will subtract it by arr of I dot begin. Why? Because that gives us iterator, so we have to remove that iterator. And this value, this all value which we will take will be in int. So I will just typecast this to int, so that the value which we will take should be int. It is not in the type of iterator. Okay. And then I will simply add this value to, let's say, current, or let's say x, because I have to add it for all the, you can see now here what we are doing it for 3 plus 1 plus 1, adding it na, to compare it with the desired value. Okay, so we are just adding it to the x. Now guys, what we want it should be r into c plus 1 by 2. So if the price, sorry, x is less than, okay, so if the given x is less than the desired value, desired means what we want. Okay, desired means what we want. So in that case what we will do, is, just a minute. Yeah, so in that case what we will do, we will simply, अरे यार तुम लोग comments कहाँ चले गए? Yeah, Joel, I am not from Chennai, yaar. Means why you are asking this? Am I looks like I'm from Chennai, or if I speak like that? Okay. So yeah, if x is less than the desired value is r into c plus 1 by 2. So this is the desired value. So if it is less than, so as I told you, we will make r min is equal to mid plus 1. Okay. And else will make our max is equal to mid minus 1. I think mid minus 1, or it should be mid, because mid should also be considered again. Okay, this is it should be mid, I think. Okay, let's do this thing. Okay, I will explain why. At the last, min will be the answer. I will also tell you why. Because oh, okay, you are from Chennai. No, 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 I am not from Chennai. Okay, my ex. I don't know that if I speak like them, but yeah, I am not from. I am from UP, UP Kanpur. Okay, yeah. So okay, uh, this is what we have, and at the last, our mid will be our answer. So what we will do, we will take another test case to understand this thing. Okay, so then it will be more clear. Fine. Okay, great. So guys, let's compile this code. Okay, so we are having MX and MN here now, but we have taken mid and max. Prithvi, you can get the link. I think that there should be uh, a playlist created for this POD live. Okay, this problem of the day live. I with Siddharth and yes will be going to take this problem of the day series from now onwards. Okay, and we will have this POD live from now onwards. Okay, so that will be the case. Fine, guys. What happened? Okay, so we are having some problem here. Maybe there we have to make mid my. Uh, I was thinking to take here like the different case. Okay, maybe that is giving, because here we have to take mid, and maybe that case is not taken. Just a minute, guys. Let me just debug the problem. Okay. Okay, here I have to make mx minus mn. Sorry, yaar. We were having some. It is giving us time limit exceeded. I don't know why, because the problem should be fine. We have basically executed this problem. Okay, this max should be less than, I think, always, because otherwise it will start. Okay, so this max should be less than min. Yeah, we have got the answer. Okay, that was the only wrong thing, and it should be fine. I think this was fine that we were doing. That was completely fine. While loop is taking infinity, because here we are making mid na, so for mid it should be less than, otherwise it will be again equal to, and it will just go infinity instead of that. Okay, during the lifetime we have some more viewers, some 50 viewers who are watching. Let's submit it, guys. It was a good problem, guys. Means yeah, you have to basically take some time to solve it, and just take your time. If you have not attempted the series, the problem, attempt all the PODs daily. Start your stake from today. Okay, just like here you will see, if you talk about a time complexity and space complexity, so the time complexity for this particular case will be the for this uh, for this basic while loop will be. So we are applying that while loop here on all the, we are applying that while loop here, this upper bound here for on the column. So if the size of the column is c, so this upper bound takes log of c. So log of c time will be taken by upper bound. Okay. Now if we talk about this, we have a for loop inside this. We have this. So time complexity will be r into log of c. And if we talk about this while loop, which is starting from minimum to maximum, so it is nothing but it will be log of the maximum value. and if we take here the maximum value of element will be 2000. So that is why it is written 32, means it will be something log of 2000 if we take just the maximum value. So it is just a constant value. So we can say that the time complexity is order of r into log of c. Okay, or we can write it like log of the maximum value also. Okay, so that is what our complexity, and our space complexity is simply order of 1. So because it is why it is order of 1, because we have not taken any excess space here. The other solution would be that if we will just iterate, the time complexity will be r into c, and space complexity will be again r into c. If we just create a new array, and after sorting it, we just output the middle element. That is a very brute force approach, but that will take order of r into c time and order of r into c space. But here what we are doing is space is order of 1 and time is r into log of c. That is what we are doing. Okay, fine then. Great, guys. I hope you have learned something new in this particular problem, that how we can implement this type of binary search too, where we can apply binary search or answer, and this type of operations has been done. Okay. So, okay, guys, then I hope that it's fine. Let's conclude the session for today. Good night, everyone. Thank you for joining and all, and solve POD for today. And we will have the solution of that POD tomorrow at the same time, which is 12 p.m. And surely we will discuss that POD. So, okay, then, guys, thank you. Good night. Have a good day. Thanks, Will. Thanks for your compliment. Thank you. Bye. Good night. Thank you, guys.